This is a number line. Often it has 0 in the center, but it doesn't always have to be that way. Anyways, as we move to the left on the number line, numbers get smaller or more negative, and it continues forever, infinitely in that direction. But of course, we don't have an infinitely long computer screen, so we put an arrow and the negative infinity symbol. Similarly, as we move to the right, values get larger or more positive, and they also continue infinitely in that direction as well. Now, plotting a point on a number line is quite easy. A number line is one-dimensional, meaning we've got one type of movement, a left and right movement. So the number 2 would be plotted at the 2 hash mark. Or we can move over to the left and plot the number -4. But you probably know that not everything in life is one-dimensional. Like, how would we tell someone the location of this point? Or this point over here? Or the point down here? None of those points lie directly on our number line, so it's impossible for us to give a precise location. We would need an up and down dimension to show that those points moved up or down. Let's bring in another dimension. This is called the coordinate plane. Notice we still have our left and right dimension, our number line. It's now called the x-axis. But we also have this up and down number line, this vertical number line called the y-axis. Okay, so let's bring back those points from earlier. Now, since we have our x-axis and our y-axis, it's quite easy to give the location of these points. This green dot has an x-axis value of 1 and a y-axis value of 2. So we would say that it lies at the point 1, 2. By the way, when we write a point like this, it's called an ordered pair. It shows the x-axis value first and then the y-axis value second. Here's the ordered pairs for the other points. Now, there's one last thing I want to mention, and it's that you should notice the x and y-axis kind of split the coordinate plane into 4 equal sections. Each of these sections is called a quadrant, and we label them in the counterclockwise direction. So here's quadrant 1, and quadrant 2, quadrant 3, and quadrant 4. So when we plot ordered pairs, we can give their location and also tell which quadrant they lie within. This point lies in quadrant 1, whereas this point over here lies in quadrant 3. Now, some points don't lie in any quadrant at all. If a point lies directly on an axis, like this point here, it's called an intercept. This point would be called an x-intercept because it lies directly on the x-axis. Of course, we can also have y-intercepts as well. Here's an example of a y-intercept. And again, since these are x and y-intercepts, we say that they do not lie in any quadrant, since they lie directly on the axis themselves. And that's just about it. As long as you understand how to plot ordered pairs, you understand the location of the quadrants, and you know the meaning of x and y intercepts, then you've got a good base knowledge for dealing with the rectangular coordinate system.